Okay, hi guys. This is my second video out of the Systems of Linear Equations section. So I had made a previous video about substitution that went completely perfectly, except I had written that one of my lines was the other line, and I was like, dang it. Since I made a mistake, let me just start over. So here we go. Basically for substitution method, at this point, we've already covered that there are three ways to solve a system of linear equations in two variables. One is using a graph. Substitution is our second method, and elimination is the third method, which you can check out in my third video, okay? So basically for a substitution method, we're taking one of these line equations, isolating one variable. Whatever that variable is equal to, we plug that into the other line equation and solve for the second missing variable. I know, sounds weird, right? But just hang tight with me for a moment. We will go over this. It's better to see it in an example or hear it in an example. So you guys can see that we have line 1 here, okay? And then we have line 2 here. Now, I want you to think to yourselves, which of these two lines would be easier to isolate one variable? Well, if we're trying to do this with line 1, we'd have to move one of the terms over and then divide by a coefficient that's out in front. So that's not the easiest. Instead, what we want to do is go with line 2 here. Okay, let me add some text. So line 2, the goal is to isolate one variable. And the easiest one is x. Okay, so let's go over this process. If I add 3y to both sides, then I get x by itself. So x equals positive 3y plus 7. Okay. Now what I'm going to do is substitute this x value in terms of y into the first equation for line 1. Okay, so hopefully you're seeing, x is x for both of these equations. Y is y for both of these equations, okay? So since I have an equivalency from line 2 of what x is equivalent to, I can go back and plug that into my line 1. Sorry, I got some bubbles popping up here. Okay. So what we're going to do, we are going to take line 1, which is 3 times whatever x is. That's 3y plus 7. And then I'm going to subtract 5y and set that equal to 17. So now I have one equation, one unknown. So it is solvable. For y. So I'm going to start by distributing. I have 9y plus 21 minus 5y equals 17. Combine your like terms where you can. I have 4y plus 21 equals 17. I am going to subtract 21 from both sides. I have 4y equals negative 4. And then I divide both sides by 4. That gives me y equals negative 1. So that's the y value that I want. Okay. This y value, when I plug it into either line 1 or line 2, it should make both of the equations true. So you just choose one to do. I'm going to back substitute y into either L1 or L2. Choose the one that's going to be easiest for you to solve. I see that x is pretty much more or less already isolated here, okay? Kind of pro tip, if you already know y, you can use this equation as well. You could use this equation just to solve for x. But general rule of thumb, go to your original equation if you're not sure. We'll find out in future chapters that you do need to check in the original equation sometimes, not your altered ones. So I'm going to use line 2. I have x minus 3 times whatever y is. Y is -1. That should equal positive 7. So x plus 3 equals positive 7. Subtract 3 from both sides. X equals 4. Go ahead and box that too. Great. We have an x and a y that should work for both of these equations. Let's go ahead and double check. So I'm going to put my 4 in for x. Be careful here that you put the right variable in. And there we are. So great. Let me go ahead and clear everything out here. We have gone over substitution method. Go ahead and check out the elimination and graphical methods at your earliest convenience. And let me know if you have any questions.